Hello, grade 9 students. In this video, we are going to learn about simplifying expressions with rational exponents. Are you ready, grade 9 students? Our objective for this topic is simplify expressions with rational exponents. Rational exponent, expressions with exponents that are rational numbers or fractions, like 8 raised to the power of 2/3. 2/3 is a fraction, and it is an exponent, and 8 is the base. So, this one is an example of rational exponent. Now, we will proceed to the laws of rational exponent or the properties of rational exponent. First is we have this product rule. A raised to the power of m times a to the power of n equals a raised to the power of m plus n. So, napansin ninyo, we add the exponent m and n. We have the same base, which is a. So, example for rational exponent is we have x to the power of 2/3 times x to the power of 1/3. So, our base is x, and our exponent are 2/3 and 1/3. So, since we have the same base, pareha yung base natin na x, we'll just add 1/3 and 2/3. So, 1/3 plus 2/3, that is equal to 1. Or x to the power of 1, or shall we say, x. So, this is how to add, use the product rule when the base are the same, we just add the exponent. Second is the quotient rule. A raised to the power of m over a raised to the power of n equals a raised to the power of m minus n. In the quotient rule, the base are the same, which is a, and we are going to subtract the exponent. That's why we have a raised to the power of m minus n. So, example for this is we have y raised to the power of 5 over 7 over y raised to the power of 2 over 7. Our base is y. Then, since we have the same base, we just subtract the exponent, 5 over 7 minus 2 over 7. And our exponent have the same denominator, which is 7. So, we will just subtract the numerator, 5 minus 2, that is 3 over 7. So, our answer is y raised to the power of 3 over 7. Next is the raising a power to a power rule. For example, a raised to the power of m. Our a is the base. Our exponent is m. And there is an exponent n na nasa labas ng parentheses. So, in this case, we just multiply the exponent m and n. So, example for this, x raised to the power of 12 raised to the power of 2/3. So, since we are going to multiply the m and n, so we have to multiply 12 times 2/3. 12 times 2/3 or 12 times 2, that is 24 over by 3. So, we only multiply 12 and 2. And we all know that 12 here has a denominator of 1. 1 times 3 is 3. Then, we all know that 24 can be divided by 3. And that is 8. So, our answer is x to the power of 8. Next, property or law. Raising a product to a power rule. B raised to the power of m. And that becomes a raised to the power of m and b raised to the power of m. Example for this is r raised to the power of 12, s raised to the power of 9, quantity raised to the power of 1/3. So, in this case, sa ating sample na a, b, dalawa yung base natin, which is a and b. So, i-distribute si exponent na m. So, that's why we have a, m, or a raised to the power of m, and b raised to the power of m. So, sa ating example, we will multiply 12 by 1. 12 times 1, that is 12. And copy the denominator 3. That is r raised to the power of 12 over 3. And another, for s, we multiply 9 and 1. 9 times 1, that is 9, and copy the denominator, 3. We all know that 12 can be divided by 3. So we have r raised to the power of 4 and s raised to the power of 3. 3 because 9 divided by 3 is 3. So our answer is right. R raised to the power of 4 and R raised to the power of 4, rather, S raised to the power of 3. Next, raising a quotient to a power rule. A over B raised to the power of M equals A raised to the power of M over B raised to the power of M. Our base is a fraction and we have our exponent, which is M. Example for this rule is we have 4 raised to the power of 64 raised to the power of 4 over 64 raised to the power of 1/2. Then we all know that this 4 is equal to 2 squared. 2 squared is 4. And 64 is 2 to raise to the power of 6. Why 6? Because 2 times 2 is 4 times 2 is 8 times 3 times 4 is 32. 16 rather. Times 5 is 32 times 6 is 64, raised to the power of 1/2. So we have 2 squared. We are going to distribute the exponent 1/2 and 2. So 1/2 of 2, that is 1. 1/2 of 6, that is 3. So our final answer is 2 over 8, or that is equal to 1/4. Why 8? Because 2 times 2 times 2, that is 8. So final answer is 1/4. For more examples, we have this. Simplify each expression and express your answer using positive exponent. Number 1. M raised to the power of 2/3 times M raised to the power of 3/4. So, sa na-observe natin, we have the same base, which is M. So, we'll just add the exponent 2/3 and 3/4. So, we will observe in this example the product rule, wherein we are going to add the exponent. But our exponent are dissimilar fractions. So we need to find the LCD of these fractions, 2/3 and 3/4. So we have 2/3 plus 3/4 equals, our LCD is 12. And 12 divided by 3, that is 4. 4 times 2 is 8. So that's why we have here 8. Next, 12 divided by 4, that is 3. Then 3 times 3, that is 9. So our final answer is M raised to the power of 17 over 12. Why 17? Because 8 plus 9 is 17. We'll proceed to number 2. X raised to the power of 2/5, Y raised to the power of 4/10. Raised to the power of negative 5. So there is an exponent of negative 5 outside the parentheses. And we have different base, which is X and Y. This is an example of raising a power product to a power rule, wherein we are going to distribute this exponent, which is negative 5, to each exponent here, fractional exponent or rational exponent, 2/5 and 4 over 10. So we have x raised to the power of 2/5 times negative 5, and y raised to the power of 4 over 10 times negative 5. And we have x raised to the power of negative 2. Why negative 2? We cancel this negative 5 and negative 5. So, naiwan sa negative and 2. So, that's why we have here negative 2. Next is 4 and 4 times negative 5. That is negative 20 over 10. Then, our final answer is x raised to the power of negative 2, y raised to the power of negative 2. By the way, we are not yet in the final answer because it has been said that it is only in simplified form when there is no negative exponent. So what would be our final answer? Our final answer is 1 over x squared y squared. So we need to put this in the denominator and our numerator is 1. So that we have this answer where the exponents are positive. Next, number 3. It is just the same with number 2. But the difference is the exponent that is outside the parentheses. For number 2, it is negative 5. For number 3, that is 1/3. So still, we will distribute the exponent. So we have 21 over 3. Why 21 over 3? 21 times 1. Then copy the denominator 3. Then Q, negative 15 times 1, that is negative 15 over 3. Then for R, negative 3 over 3. Then we have here exponent for P, which is 7, because 21 divided by 3, that is 7. Exponent for Q, that is negative 5, because negative 15 divided by 3, that is negative 5. And exponent for R is negative 1, because negative 3 divided by 3 is 1. And our final answer. You'll know that RQ and RR has a negative exponent. So, ang maiwan, our final answer would be P raised to the power of 7 over Q raised to the power of 5R. Nasa baba si Q and si R because their exponents are negative. And since nababa na natin si Q and si R, ang ating final answer is this one. Next, number 4. 16x raised to the power of 6 raised to the power of 1/2. So that becomes, our 16 becomes 4 raised to the power of 2. Why 4 raised to the power of 2? Because 4 times 4 is still 16 times 1/2. Then x raised to the power of 6 times 1/2. Then we have 4. Why 4 only? Because 1/2 of 2 is 1. So we only have here 4. 6 divided by 2, that is 3. So our final answer is 4x cubed. For number 5 example, x raised to the power of 3/2 over x to the power of 3/4. So this example is an example of quotient rule wherein we have the same base and we will subtract the exponent. But our exponent here are dissimilar fractions. So we have x 3/2 or x raised to the power of 3/2 minus 3/4. And that is, we will look for the LCD of 3/2 and 3/4. And that is 4. 4 divided by 2 gives us 2. 2 times 3, that is 6. 4 divided by 4, that is 1. 1 times 3, that is 3. And we have an answer of x raised to the power of 3/4. 3/4 because 6 minus 3, 3. And copy the denominator 4. So this is our final answer. Next, number 5. Number 6 rather. 2 raised to the power of negative 4/3 over 2 raised to the power of negative 5/6. In this case, we will find the reciprocal first of these two fractions expression because their exponents are negative. And that would be 2 raised to the power of 5 over 6 over 2 raised to the power of 4/3. Still, we are in quotient rule where our base is 2 and our exponent are fractions, but the fractions are dissimilar fractions. We will look for the LCD of these two fractions. So we have an LCD of 6. So 6 divided by 6, that is 1. 1 times 5, that is 5. Then 6 divided by 3, that is 2. 4 times 2, that is 8. And we have 2 raised to the power of negative 3 over 6. Negative 3 because 5 minus 8 is negative 3. And we reduce this negative 3 over 6, our exponent, that becomes negative 1/2. We all know that we can say that an expression is in simplified form when the exponent are all positive. So we make sure that our exponent becomes positive. So we have 1 over 2 raised to the power of 1/2 as our final answer. For number 7. Number 7, m raised to the power of 1/3 and raised to the power of 2 quantity raised to the power of 1/2. So in this case, this is an example of raising a product to a power rule wherein we are going to multiply the exponent. So 1/3 times 1/2 or negative 2 times 1/2. So we have 1 over 6. 1 times 1 is 1. 3 times 2 is 6. Then, negative 2 times 1, that is negative 2. Then, we all know there is an denominator here of 1. 1 times 2, that is 2. And we have m raised to the power of 1/6 over n to the power of negative 1. Or, again, m raised to the power of 1/6, n raised to the power of negative 1. We make sure that all of the bases has negative or positive exponent. So, our final answer for this expression is m raised to the power of 1/6 over n. Again, m raised to the power of 1/6 over n. For the next slides are your exercises related to rational exponent. Please answer those exercises so that you can familiarize all the laws of exponent involving rational exponents.